Okay, we are looking at lesson 2.4, day 2. So hopefully you went on and did lesson 2, or you went and did lesson 2.4, day 1 homework last night. That was at page 205, and it had numbers to go with that. Okay, I know some of you virtual have already sent it to me, and that's great. If we probably will get a chance to check it, so I don't necessarily have to have it today, but I would go ahead and send it in as soon as you get it done, so you don't have to worry about it. Tonight, there will be a new homework on page 205, so you've got 2 different homeworks on page 205, and I've got the numbers written down at the bottom of the screen for that one. We're starting into synthetic division today. We're going to practice one synthetic division problem, and then we're going to use it to talk about something called the rational roots theorem. Technically, it falls into chapter 5 in Algebra 2, which is right before Christmas break. However, I'm not sure if I really got to do this last year with you or not, so we may or may not have gotten to do much with it. But let's still practice our synthetic division. So use synthetic division to divide f of x by x minus 3. Write the summary statement in fraction form. So, I don't know how much you guys remember about this, but I start with a box up here. And in that box, I'm going to put the number that we use as our divisor. Think back yesterday to our k value. What would be our k value here? Yeah. Since this is x minus 3, think about setting it equal to 0. And we're going to use 3 as our k value. Yes, we are. Sorry, Keaton's back there shaking his head at me. So now, then remember we're going to write a row of numbers next to it. This row of numbers represents the coefficients in your polynomial here. Now, the one thing to remember is that make sure, just like in long division, every power is represented. So here, my first coefficient is 2 because it's 2x to the third. So then I need a coefficient for x squared, x, and the constant. So make sure you put placeholder zeros in if you need them, or when you need them. So here we're going to have 2. It's negative 3 comes from x squared, negative 5 from x to the first, and negative 12 is my constant. Leave a room for a row of numbers, and then I draw a line. Okay, that's my synthetic division setup that I typically use. Do you remember the first step? Not the 3. We're going to drop the 2 down. Okay, so yep. Your first step is always to drop the first number in what you're dividing. So we're going to drop the 2 down. That's the first number in my answer. Okay. Then it's always multiply, add, multiply, add. You alternate those steps. So we're going to multiply this 3, and in this case it's 3 times 2. 3 times 2 is 6, and it's going to go over here underneath the negative 3. We multiplied. Now we add. So now we're going to add negative 3 plus 6, which is 3. Repeat the process. We multiply. So this time I'm going to multiply 3 times.
How did the 3 appear to them?
This 3 right here came from adding. Negative 3 plus 6 is 3. It's always multiply and add are the 2 steps. Mm-hmm. Okay? And so now we're going to multiply. We always go back and grab this 3 here times our newest number here. 3 times 3 is 9. 9 sits under negative 5. And we add. Negative 5 plus 9 is 4. And we multiply now. 3 times 4 is 12. And we add. Negative 12 plus 12? 0. What does that 0 represent? That is my remainder. Okay. That last value there is always your remainder.
So
It doesn't have to necessarily be a 0, but it's always your remainder. Yep.
The last number.
The last number, yes. That last number is always your remainder. The other numbers represent your answer. Now, keep in mind, we started up here with 2x to the third, right? We divided by x to the first. When you take x to the third and divide by x to the first, this is going to represent 2x to the second, and then it counts down from there. So your power in your answer is always 1 less than the power we started with. So if I start with the power of 3, this is going to be 2. So my answer here is going to be 2x squared plus 3x plus 4. Okay? That is your overall answer there. Now, the one other thing I can comment on is when it says write a summary statement in fraction form, they're just talking about the two pieces we divided, make those a fraction. So in this case, we did 2x cubed minus 3x squared minus 5x minus 12 divided by x minus 3, and that equals the 2x squared plus 3x plus 4. That is the fraction form that we're talking about there. Okay, synthetic division sound a little familiar for those of you that have seen it before? Okay, it's not a difficult thing to use, and we're going to use it as we talk about this rational roots theorem that we're talking about. So, rational roots theorem. The vocabulary here says, suppose f is a polynomial function, degree 1 or bigger. Then, if that's x equals p over q. Okay, if x equals p over q, p is an integer factor of the constant coefficient, and q is an integer factor of the leading coefficient. So p is an integer factor of the constant, and q is a factor of the leading coefficient. Now, let's put it into words. Easiest way for me to explain this is to jump right into our example. Okay, that's the easiest way for me to help you understand it. So, I want to jump right into example 2. And when we talk about this rational roots theorem, what it does is it helps us find any possible rational roots. Okay, in example 2, the question asked me to find the rational zeros. Means on this particular problem, we don't want any irrational zeros. We just want rational zeros. So remember, those are zeros that can be expressed as a fraction. So I'm going to come all the way over to the left. And I don't know, if I talked about this last year in Algebra 2, you might remember me talking about PRRs. Okay, PRR stands for potential rational roots, or possible rational roots. And I'm going to put that right here so you have it as a reminder. Potential rational roots. So when we start talking about trying to find our PRRs, or potential rational roots, we're going to use that rational roots theorem, and what we're going to find is a list of possible roots. Are they all going to work? No, that's why they're possible or potential rational roots. But they're going to be possibilities, and your rational roots are in that list somewhere. Okay? And realize when I'm talking about roots or zeros, we're talking about solutions to these problems. Okay? So, for PRRs, remember up above it said x equals P over Q, where P is integer factor of the constant coefficient. What is the constant in this problem? 4. Remember, your constant is your number at the end that does not have any letters on it. So on top here, we're going to do factors of 4 divided by Q, which is factors of the leading coefficient. What's my leading coefficient? Okay, yeah, whatever number is in front of x cubed, because x cubed is my leading term, and so my leading coefficient, in this case, is 1. So my denominator is going to be factors of 1. So I've got factors of 4 over factors of 1. Okay, what are factors? What are the factors of 4? 2 times 2 and 1 times 4. So if I list those, now keep in mind, it did say integer factors, so we're going to use positives and negatives here. So I'm going to say plus or minus 1, plus or minus 2, and plus or minus 4. Those are my integer factors of 4. We don't need to list 2 more than once. What are factors of 1? Plus or minus 1. We like that one, right? Now, whenever we list our PRRs, our potential rational roots, I'm not going to leave them in this fraction form. I'm going to go through and pair them up. So like in this case, I only have one number in the denominator, and that's the 1, right? So what is 1 over 1? 1. So plus or minus 1 is option. What's 2 over 1? 2. 2 divided by 1 is 2. So we have plus or minus 2. And what's 4 over 1? 4. So my potential rational roots, plus or minus 1, plus or minus 2, and plus or minus 4. Now, this is not what the question is asking for the end result. Sorry, get zoomed out a little bit so everyone can see what I wrote. But this is if you're asked for just your potential rational roots. So no matter what the rational roots are, so no matter what the solutions are, the rational ones are included in this list. Irrational ones are not. We have to do something different to find those. Now, we need to figure out which one works, or which ones work. And this is where we're going to use synthetic division. Because we can take any of these numbers we want, plus or minus 1, 2, or 4, and we can try them using synthetic division. How will I know if something works?
If it's a false remainder.
If it has a remainder of 0. Okay, that's going to be the whole idea. Now, there's technically 6 different numbers here, aren't there? And when I teach this in Algebra 2, that means we take turns and we keep trying something until we find one that works. And we can use that idea in pre-cal. That works. However, do we want to kind of cheat and take a shortcut here?
Yes, please.
What would help speed up the process of telling us which one might work or which ones might work? Because Algebra 2 doesn't have these handy-dandy graphing calculators. How can my graphing calculator help me? Where do we find where are we going to find zeros? X-intercepts. So if I graph this, okay, I have something that looks like this, right? And I am going to put a little sketch in the sketch here in my work. But it looks like I have something that crosses through just left of 0, around 2, and I think it just passed 6. Now, this is just a sketch. Just trying to get you the idea of, okay, the calculator shows something like this. Based on this graph, what values should I try from my list of plus or minus 1, 2, and 4? Well, which ones does it look like are zeros according to my graph? Does it look like it probably cuts through 2 if you look at your calculator? Yeah. Does it look like it crosses through negative 1? No, it's something between 0 and negative 1. Does it look like it crosses through 6? Which actually 6 isn't even on our list, is it?
No.
Okay, so these two right here, because they don't match up with anything in this list, they're going to end up being irrationals, and we're not going to have to find them on this one. But we want to try, based on this graph, we're going to try x equals 2. So I'm writing right here, based on the graph, I'm going to try x equals 2. If you didn't have the graph, what would you have done? You'd try 1. You'd try negative 1. You'd try 2. You know, you just have to try several things until you found a working one. We're just using the calculator to help kind of speed it up a little bit. So when I say try 2, that means I'm going to use synthetic division. 2 goes in the box. And then what numbers go next to my box? 1.
Minus 8.
Negative 8.
Plus 10. Plus 4.
10 and 4. Okay, do you remember how to do your synthetic division now? Drop the 1. 2 times 1 is 2. Negative 8 plus 2? Negative 6. 2 times negative 6? Negative 12. 10 plus negative 12? Negative 2. 2 times negative 2? Negative 4. And 4 plus negative 4? 0. What's that 0 tell me? It works, right? This tells me that 2 works because there was a remainder of 0. Now, that means at this point I have found one rational 0. It is slightly possible there are others. However, based on looking at the graph and the list, we kind of know there's not. But I want to look at a little bit here of how to finish this up, because this will, even though it doesn't really play an important role in this problem, it will in other problems. First of all, what does this 1, negative 6, and negative 2 represent?
X cubed, X squared.
Not x cubed. If up here the 1 was x cubed,
Oh, X squared.
down here this is x squared minus 6x and minus 2, right? So if we look at this function in a factored form, which is my last step that we're going to do here. Let me move over and zoom in here a little bit. First of all, we know one factor is based on a 0 of 2. Yes? We know there's a 0 of 2, so one of my factors is x minus 2 at this point. What's the other factor? Our remaining pieces of x squared minus 6x minus 2. Okay? And this is, more than anything, this is going to be where you're going to find your irrational zeros. Okay? We've already discussed that one of our solutions is, or a solution, is x equals 2. My question to you, if there's any other rational solutions, this will factor. Does x squared minus 6x minus 2 factor? And it does not factor. Well, I can't get a product of -2 and a sum of -6. Since this does not factor, these are going to be irrational roots. So the only rational root in this problem is x equals 2. I'm going to write myself a note here. Does not factor. And since it does not factor, these are irrational roots. Okay, and if we needed to find those irrational roots, we could do something like quadratic formula, but that's not asked on this particular question. Okay? Okay. I'm ready to try the next example when you guys are. I know my morning class, I ran out of time, so I'm hoping not to run out of time here, but I know it's going to be close. This next example is similar to the last example because what does it ask for? Rational zeros. Okay, so start off the same place. I want you to find your PRRs, potential rational roots. Okay, if you recall potential rational roots, according to the theorem, it's P over Q. What is P? Coefficient? Yep. Okay, so integer factors of the constant coefficient, what's my constant? -2. So on top, I'm doing factors of -2. Denominator is factors of the leading coefficient, which is 3. So factors of -2 over factors of 3. Don't worry about the negative. What are factors of 2? 2 and 1. So plus or minus 1, plus or minus 2. What are factors of 3? 1 times 3. Now, again, what I said earlier. Don't leave them like this. Write them out to be individual numbers, which means in this case, take turns putting each numerator over each denominator. So here, I would start by putting everything over 1. 1 over 1 is 1. 2 over 1 is 2. Now we're going to take turns putting things over 3. 1 over 3 is 1/3, plus or minus 1/3. 2 over 3, plus or minus 2/3. So these are my potential rational roots. Yes, you can have fractions because fractions are rational. Doesn't mean they're fun, but we can have them. Now, take a peek at the graph if you want to speed this process up. Okay? I'm going to, while you guys are taking a peek at the graph, I'm going to go ahead and work on sketching it here. You guys realize I'm not drawing these graphs accurate. I'm just trying to make a point of what do we have to look at here. Looking at those zeros. So based on your graph, what ones do you think you should try? -2?
-1/3.
Ooh.
Maybe +2/3.
Okay. This one right here, I was going to put a question mark here.
Oh no, so no 2/3, not +1.
Okay. So I was going to put a question mark here, But Hans is suggesting maybe this is a negative 1/3. Could that be possible? It could be. Now, I'm not as confident about it as I would be like -2. I feel confident looking at the graphing calculator. The 1, do you guys feel pretty confident about that one also? Okay, but this negative 1/3, maybe. Okay, and that's something for me where I'm going to try the obvious numbers first and then the graph. Yes?
Could you find your zeros with the calculator?
You can, however, you still have to show this work. Because based on the methods we're using right here, this isn't just using, I'm just using a calculator to try and speed up my process. Yes. And the thing is, if you do the wrong numbers, that is part of the process of, you sometimes have to redo something. Okay, so I'm going to say, based on the graph, and I'm just writing this so when you look at it later, you have some inkling of what we did. Based on the graph, we're going to try x equals -2, 1, and maybe negative 1/3. So when I do this, I'm definitely going to be more likely to try -2 and 1 first. And when I say try those, that means I'm using what? Synthetic division.
We need to find even the irrational roots.
We do not have to find the irrational in this one. Okay? Now, I would try either -2 or 1 first. It doesn't matter which you try first. So if I use -2, then I'm going to have 3, 4, -5, and -2. Drop the 3. -2 times 3, -6. 4 plus -6, -2. -2 times -2, 4. -5 plus 4, -1. -2 times -1, +2. And -2 plus 2, 0. So what do we know right here? -2 works because there's a remainder of 0. Now, okay, what do we have to try next? We need to try 1. Now, hear me. Don't go back and use your original row of numbers. We just created a new row of numbers. And it is important, especially if you had to find the irrational roots, that use your new row of numbers. For me, since I used -2 first, this is my new row of numbers. If you used 1 first, you might have a different row of numbers, but it's still, you have to use your new row of numbers when we try our next possibility, which for me is 1. Everyone hearing that? So now if I try 1, I'm using 3, -2, and -1. Are we okay virtually, or were we just commenting? Okay. Okay. I know, it's hard for me to know who's going to respond and who's not and when, so. Okay, have you guys done this one? Does it work?
Yes.
Drop the 3. 1 times 3 is 3. -2 plus 3 is 1. 1 times 1 is 1. -1 plus 1 is 0. So 1 works. Now, you don't have to do any more synthetic division. Here's my recommendation. Okay. What does this 3 and 1 represent right here? So if we backtrack, this original 3 was 3x to the 3rd, which makes this 3 down here 3x to the 2nd. Carry it over, this is 3x to the 2nd. What does that make this one? 3x. So this is, if we go off of this right here, 3x plus 1. Set that equal to 0, and what do you notice? (3x plus 1 equals 0). If you start solving that, subtract 1. 3x is negative 1, and x is what? Negative 1/3. So now, what are my rational zeros? Okay. Negative 2, 1, and negative 1/3. So, x equals negative 2, 1, negative 1/3. Now, I know the question was asked in my morning class, do you have to do the synthetic division to show that? The graph showed us this. Yes, you do. And it has to do with, as we move towards some more complicated problems, like this last example, you have to have that information, okay? Because the calculator is not going to give me everything I need. Now, with any luck, I can get through this last problem better than I did this morning. What is the difference with this last problem? Okay, it's x to the 4th instead, but it also says what? Find all of the real zeros, which means I need rational and irrational. The last one I just did, they were all rational. The previous one we did, we had one rational, the other two were irrational, so we just skipped them. We don't get to skip anything here. Now, can I go through the beginning part of this pretty quickly? Where do we start? PRRs. Okay, potential rational roots. So we're going to do x equals P over Q. What's P? Factors of the constant, which are 8. What's Q?
Factors of 2.
Factors of the lead coefficient, which is 2. What are factors of 8?
1.
Yep. Okay, so in class I heard 1, 8, 2, 4. I just put them in order. What are factors of 2? 1 and 2. You like it when there's easy small ones. Now, when I go through, I'm going to list these, right? Let's go through and put everything over 1. 1 over 1 is 1. 2 over 1 is 2. 4 over 1 is 4. 8 over 1 is 8. Now, we're going to go through and put everything over 2. 1 over 2?
Plus minus
1/2. 2 over 2?
plus minus 1, which we have.
It's 1, which we already have. 4 over 2? It's 2, which we already have. 8 over 2? It's 4, which we already have. Do I need to relist things I already have? No. And I didn't really say it, but all of these have a plus or minus with them, correct? So those are my potential rational roots. EGADS, that's a lot. That's when we're thankful for the graphing calculator to give you an idea. Again, I'm trying to save time because I'm trying to race the clock here. I'm trying to win against the clock. What can I say here? See what you can find on your graphing calculator. What are the ones that we should try? Okay, you got any you think we should try?
Minus 0.5.
Could that possibly be a negative 1, a negative half? Very possibly, right? It's between 0 and negative 1. And negative 1/2 is in that area, so it's a possibility. Anything else we should try? 4? 4 is a definite in my book. In fact, that's where you'll find me starting. Now, the others are between 1 and 2 and negative 1 and 2. Do we have anything in that area?
No.
No. So those are probably irrational. Okay, I'm going to write down that we're going to try x is 4 and negative 1/2. Again, it doesn't matter which you start with. Of course the password is incorrect. I was even so careful on how I typed it. Like, it doesn't matter how slow and careful I type in that situation. It comes up wrong every time. Okay, so I'm going to try 4. Putting my numbers in, 2, negative 7, negative 8, 14, and 8. Drop the 2. 4 times 2 is 8. Negative 7 plus 8, 1. 4 times 1 is 4. Negative 8 plus negative 4. 4 times negative 4, negative 16. 14 plus negative 16, negative 2. 4 times negative 2, negative 8. And 8 plus negative 8, 0. So what do we know? 4 works. Shocker, I know, right? Okay, what's the next one I'm trying? Negative 1/2. Guys, don't be scared of a fraction. It's not that bad, I promise. Now, what numbers am I using here? Your new row of numbers, yes? Do not go back. This is incredibly important on this problem. Do not go back and use the original problem here, or you won't be able to find your irrational roots. So I'm going to use 2, 1, negative 4, negative 2. And I don't need the 0. Drop my 2. Negative 1/2 times 2. Half of 2 is 1, and it's negative. 1 plus negative 1, 0. Negative 1/2 times 0, 0. Negative 4 plus 0, negative 4. Negative 1/2 times negative 4, 2. Negative 2 plus 2, 0. Okay, so negative 1/2, it works. Now here is the key to finishing this problem. What does this 2, 0, negative 4 represent? 2x squared minus 4? Because look at this. It was originally 2x to the 4th, so this becomes 2x to the 3rd. 2x to the 3rd, 2x squared. So 2x squared, 0x minus 4. Take that, I'm going to bring it over here so I have a little bit more room, set it equal to 0. And solve. Okay? If I add 4 to the other side, 2x squared equals 4. Divide by 2, x squared is 2. How do I solve when I have x squared equals 2? Square root. What happens when you square root in an equation setting? You have to put a plus or minus. And so, what did we just find?
Another root.
Plus or minus square root of 2, that's positive square root of 2, negative square root of 2. These are my irrational roots. Because square root of 2 is irrational. So, what did the question want? All real zeros. So we found, yes, those are numbers in between. We found 4. We found negative 1/2. We found positive square root of 2. And we found negative square root of 2. We found 4 zeros. Ethan just asked, are those the numbers that were in between? Yes. Square root of 2 is 1.4. Negative square root of 2 is negative 1.4. Okay. Make sure you get that copied. The homework for tomorrow is up there. You will need to have both ready to go. Okay, it's page 205, 7 through 10, 25, 26, 33 through 35, 50, 53, and 54. It's not as, it's not as bad as you think it is because keep in mind, it's really spread out. However, this is rational, it is doing what you're doing here on some of them, so. Virtual, let me know if there's any information I need to share with you that you didn't get.
Have a good day.
Thank you, you too.
Sorry, I didn't see it. Oh, thank you, sir.
We just have a collision.
Yes, I did. I need a police report and your turns.